call is now being recorded.
Okay, salam sejahtera and welcome back. So today we will start a new topic, electric current and also direct current circuit. Okay, so for the first subtopic, 3.1, we will learn electrical conduction. Okay, so let's start. Okay, so in this subtopic, we need to describe the microscopic model of the current. Okay, so it's actually emphasized on the flow of free electron in a metal. Okay, include the concept of drift velocity. Okay, so electrical conduction in the metal. Okay, so in the metal of the charge carrier is actually free electron. Okay, so free electrons is a charge carrier, and a lot of free electrons are available in it. Okay, so they are moved freely and also randomly. Okay, so meaning that it will move randomly, move anywhere that the electron like. Okay, bergerak secara rawak. Okay, throughout the crystal lattice structure of the metal, but frequently interact with the lattice. So when the electric field is applied to the metal, okay, so when we apply the electric field, meaning that when there is a power supply, okay, when there is a potential difference, electric field is applied to the metal, okay, the freely moving electron experience an electric force, okay, meaning that the electron will attract to the positive plate and tend to drift with constant average velocity. So we call it as a drift velocity. Okay, towards where? Towards a directions opposite to the directions of the field. Okay, opposite to the directions of the field. Okay, so we look at the diagram below. Okay, so this is a electron. Okay, so this is an electron. Okay, so electron will move in opposite directions with the electric field. Okay, so we look at here. Okay, if this is the terminal positive, meaning that here is a terminal positive. Okay, this is terminal positive. Okay. Okay, so this is a terminal positive. Terminal positive meaning that your electric field is from positive to negative. Okay, so your electric field is in these directions. Electric field is in this direction. However, your electron will attract to a terminal positive. Okay, so this is an electron, and electron it will move to the terminal positive. So that's why the question just now the statement say the electron will move to a terminal positive. Okay, however, your electric field is in opposite directions. From terminal positive come up to and then enter the terminal negative. Okay, so similar for this diagram. So here is the battery. This is the battery. Okay, so this is the battery. This is the battery. So battery, the current come out from terminal positive. Okay, but the electron will come out from terminal negative. Okay, so that's why the electron will move in this direction, in anti-clockwise direction. Okay, however, the current will move in clockwise directions. Okay, so this one not at here. Okay, this one you must okay, you must understand the directions of electric field or the electric current is from positive to negative terminal. Okay, this is from positive to negative. Okay, so this is the current and also electric field. Okay, directions of electron is negative to positive, right? Because it's come out from terminal negative and then it goes to the terminal positive. The electrons accelerate because of the electric force. Okay, why we have electric force? Because our equations okay, our equation F equals to EQ. Okay, when there is a potential electric field, and when there is a charge electron, so it will experience a electric force. Okay, so this one you must go back to chapter 1. Okay, when there is a electric field and there is a charge, okay, so for this charge is electron, so automatically it will experience a electric field. Okay, so then the electric current is flowing in opposite directions to the electron flows. Okay, so the current also will flow from positive to negative. Okay, so this is the directions. Okay, remember our current come out from terminal positive. Okay, whereas our electron must come out from terminal negative. Okay, so we continue. Okay, we continue with the page 57. Okay, define electric current. Okay, so electric current is defined as the total charge. Okay, total charge flowing through an area per per unit time. Okay, so meaning that we can write our equation is equals to dq over dt, the rate of the charge flow. Okay, when there is a charge flowing through an area, meaning that there is a current, current will produce. Okay, so current is a base quantity and also is a scalar quantity, meaning that we only consider the magnitude, okay, without considering the directions. Okay, unit for the area, unit for the current is ampere. Okay, unit for the current is ampere. Okay, so it's a scalar quantity. Okay, 1 ampere of the current is defined as 1 coulomb of charge. Okay, 1 coulomb of charge passing through the surface area in 1 second. Okay, so we can write it as 1 ampere equals to 1 coulomb per 1 second. Actually, it's from where? It's from this equation. From this equation, I equals to dq over dt. Q is the charge, so it's 1 coulomb. T is the time. Okay, so it's 1 second. So we can write it as 1 ampere equals to 1 coulomb per 1 second. Okay. Okay, next one. Okay, we go to, okay, remember, this is what we have learned also during chapter 1. Okay, I equals to dq over dt, where q equals to ne. Yeah? E is the charge. Okay, E is charge. Okay, so E is charge. This charge here, if you don't know, you can always press calculator. Constant. Okay, constant 23. Okay, constant 23. So charge value is 1.6 times 10 to the power of negative 19 coulomb. Okay, so the value is always equals to 1.6 times 10 to the power of negative 19. Okay, if this is a proton, so you put positive. If this is an electron, you put negative 1.6 times 10 to the power of negative 19. Okay, so this is, let's say this is a positive charge. Okay, if let's say this is an electron, so you can substitute negative 1.6 times 10 to the power negative 19. Okay, so this is the difference, but the value is still the same. Okay, a silver wire carries a current, so they give you I. Okay, given that the charge of the electron, okay, so this is the charge given. Determine the number of electron. They want to find the number of electron n per second. Okay, pass through the wire. Okay, so we want to find n per t. N per t. Okay, so we know that I equals to dq over dt. Okay, but charge we don't have, so we can substitute. We can substitute q equals to n, okay, times the charge over t. Okay, so now you want to find n over t. Okay, n over t. So therefore, our n over t is equals to the current over the charge. So our current is 3. Charge is equals to 1.6 times 10 to the power of negative 19. Okay, so you will get the answer equals to 1.88 times 10 to the power of positive 19. Okay, electrons per second. Okay, so this is the answer for example 1. Okay, next we go to the 1b. Okay, they ask you to find the amount of charge flow. Okay, the amount of charge flow. We want to find Q. through a cross-sectional area in time given 55 seconds. Okay, 55 seconds. So our Q, okay, or we can write I equals to dq over dt. So now we want to find Q, meaning that our Q, okay, is equals to current times the time taken. Okay, where your current just now, the questions given is 3 ampere and the time now is 55 seconds. So meaning that the answer is 165 coulomb. Okay, so this is example 1. Okay, so that's all for today. Okay, your homework for today is example 2. Okay, example 2, this is your homework. Okay, where they give you the current, okay, then they ask you to find the charge, okay, in 5 minutes. So minute, you need to change to second. Okay, okay, how many electrons the bulb in 5 minutes? So meaning that you want to find n. Okay, so after you find the charge, you can use okay, or you can use the current to find the, okay, after you find the charge just now, okay, from the current, so you can use Q equals to NE, yeah, okay, and then just now the charge I is equals to dQ over dt, so you can find your Q, okay, where your Q equals to IT. Okay, so this is your homework, this is your homework. Okay, thank you class, see you in the next video.